Alright folks, today we're going to talk about how we're doing amplitude modulation there with little spectral images on the sidelines. Basically folks, we're going to get into how did I do this. So we got the amplitude modulated signal here, and then on the left you got this kind of spectrum image scrolling in the waterfall. And today we're going to walk you through how to do it. See the link below this video. It's got all the MATLAB scripts, the GNURadio files. You're going to need MATLAB. You're going to need some kind of vector Siggen or the red Papaya. And I'll get into that in a future videos, how to set that up for those interested. But for now, let's just talk about how we set everything up. Alright, so the basic idea is we got some kind of USB microphone or some kind of microphone in your computer. Nothing fancy here. We got a binary IQ file that we make in MATLAB, and I'll walk you through that. We take these two inputs and we're going to feed that into GNURadio, do a little MATLAB, do a little mathematics, do a little shifting and fritting, flip some signals around, do some mathematics, and we're going to create essentially left-right audio signals, and we'll send that out of GNURadio, and we'll be sending these left-right audio signals to our vector Siggen, and they will be going into the IQ inputs of your vector Siggen unit. Now, some good old vector Siggens you can buy on Fleabay is the SMIQ. I mean, this is kind of an old beast, but it's relatively cheap these days. You know, it's an old clunker there, so you can pick them up pretty cheap. Another one you can get with a pretty decent price, again an oldie here, is the Agilent ESG vector Siggen, and these are also on eBay there, people selling them. Now, if you really got a lot of money, you can get Roden Schwartz's latest vector signal generator, the SMW200A. This signal generator costs about $250,000. So, you know, if you really want the top of the line and want to play with the top of the line radio exciter, this unit right here is pretty much going to do whatever you need to do. No problem. Now, for those of you that say, yeah, right, I agree. But you don't have to spend a lot of money, and stay tuned for future videos because I'm going to hopefully get one of these things, these red Papaya StemLab 125-14. Basically, it's a DAC that's running at 125 megahertz. Basically, we can get any signal from 0 to 60 megahertz output. It's a 4-bit DAC. And if I get this working with GNURadio, because it's an all-digital IQ modulator, this will be the best HF exciter, period. Now, its max power is probably going to be 0 dBm, so you're going to have to put an amplifier next to it. But you will have full IQ control with this thing. So give me a few weeks, let it show up to my lab. I'll set it up. I'll do some videos on how to set it up. But basically, for $300, we're going to see that this thing is going to be pretty powerful. And not only will it be an HF exciter, it also has two other inputs that can turn it into a scope, a spectrum analyzer, basically the Swiss Army knife for engineers out there. And I really have to thank my YouTube fan R7 for doing this. This is a great suggestion, and I figured we're going to give him some credit for suggesting the red Papaya. Alright, so this is an idea of how it's going to work with the red Papaya once I get this installed, but the idea is still the same. We're still going to use GNURadio, but now we'll be sending the IQ data by Ethernet. Very simple. Alright, well, first thing you got to do is you got to make some image files, you know, fire up Microsoft Paint there, make the picture 800 by 800, make the whole picture black, and then on the left side of the image, basically draw whatever you want. And why do I say the left side? Well, because this side is where the AM signal is going to be. So you don't want to really put anything in the images on this side. You can, but then the AM signal will be there. So the idea is you want all the stuff in the waterfall, like characters or whatever, you want that to be on the left side of the image like I did here. So just follow my steps and you'll be golden. Okay? Now what you do is once you make your 800 by 800 image, you just make that in Paint like this. We're going to read that into MATLAB, run my program. Again, the program's in the link below this video. It's going to make a binary file that GNURadio can read in. Alright, pretty busy, but here's the GNURadio script, and again, it's, just follow it block by block. It's not that hard. So basically, this is your audio source from your USB microphone or your microphone input on your computer. We'll send that through bandpass filter, 50 to 5K. Alright, then we got this modulation thing here. We're multiplying it by 1.2. Adding a constant, we're just basically doing the AM radio equation, right? Now this is all we're gonna then multiply this by 5 kilohertz, and then we read in the file here, and this scale factor is just to scale the image. And when you run it, you'll see these two slider that you can control. One is for the amplitude modulation index, that's this guy. And this one here is for this. So if the images are too strong or too not very easy to see, you simply just slide this image scale down to 0.1, 0.01 to get it just above the noise. You'll play with it, you'll see what I mean. Alright, then we convert it back to float numbers here, and here's our left-right audio signals that we then feed out of the PC sound card. And the idea is then you would take those audio signals and feed them to your vector signal generator. Now, for those of you that have the analog vector signal generator, if you want the amplitude signal to be at 3885, then you're going to have to set the center frequency on the SMIQ to 3880. Because coming out of the sound card, we're shifting the amplitude signal up by 5 kilohertz. Two main reasons why we did that. One, you can't send DC signals out of a sound card. Those sound signals are what's called AC coupled. So if I sent the AM signal at baseband, it would not work, okay? So that's why in GNURadio we're multiplying it by 5 kilohertz. No big deal, that's just a limitation of the sound card, but we're getting around it. And then on the other side of the AM signal will be the waterfall images. Alright, well, hopefully that's enough for you guys to get started. Again, see the link below. Whole bunch of good stuff there. And stay tuned for more videos on this red papaya thing. If it goes based on what I've studied, if it works as good as what it seems to, it might very well be the best HF exciter for 300 bucks, bar none. And I'll get into it later, but the real reason is because the IQ modulation in the red papaya is being done entirely in firmware. So all that is being done behind the DAC, and what that means is that all the IQ and balance and everything is minimized because it's all done before the DAC and it's being done in firmware. And there's a lot of people that have worked on this, converting these things into SDRs, transmitters, and receivers. I'm going to focus on just the transmit part because there's already plenty of receivers out there. But if I get this thing working as an HF exciter, man, for 300 bucks, folks, you are going to have one kick-ass HF exciter. You'll be able to do 20 AM radio signals at once, maybe AM, lower sideband, FM, all at the same time. You see, folks, when you're an engineer and you know the mathematics, you don't need any nanny controls. You can basically do whatever you want. So for those of you, get your engineering degree, keep studying, and keep learning. Thank you for watching, and have a great